I would now like to introduce Mike Sheppard, Deputy Director at Lancaster University. Mike is a member of the Chartered Institute of Building Services Engineers, a Fellow of the Institute of Hospital Engineers and Estate Managers. Mike heads Lancaster University's Department of Infrastructure and Maintenance. He has actively been involved with the renewal of the university's major mechanical and electrical infrastructures. He has also helped produce Lancaster's university carbon reduction policy. Delegates who attended last year's conference in Manchester will recall Mike's excellent presentation on a route map to sustainable infrastructure at Lancaster. The difficulties he experienced installing this infrastructure whilst having to maintain a fully operational university. I think that's something that we all can relate to here. For this paper, Mike won the Association's 2010 Tom Bradley Award for the best member presentation at the conference. I look forward to Mike's presentation today on wind power generation. With this, now I'll hand you over to Mike.
Right. Everybody hear me okay? Yep, no problems, good. Same as a professor, I have a tendency to wander off. So if you could just wave me to say come back, I'd appreciate it. Right. What have I come along to talk to you today? I've come to share experiences with planning, site constraints and issues associated with constructing a turbine, more to do with the planning. In 2009, it's 2 years now, in 2009 we started this process. Put a team together, had a workshop, a full day workshop, set out what we planned to do, and off we went. We're 2 years later. And people who work with my colleagues and senior managers keep saying to me, what's taking so long? Why are you spending so much money? How difficult can it be? You're only constructing a simple structure in a field. So hopefully, maybe some of those colleagues and senior staff members are watching, and perhaps they might have some better appreciation of why it's taking so long and why I'm spending so much money. My own, I don't know whether you know, but the Chancellor at Lancaster is Chris Bonington, and I've likened getting planning permission for a wind turbine to climbing Mount Everest. I think they're on an equal par. And to put some numbers to that, because I've become quite a wind turbine bore. My own family and friends just get fed up of me now talking about it. I was on Saturday evening, I was talking with a developer from a UK wind turbine developer. He's a director there, excuse me. And he said to me, in the last 5 years, he'd looked at 28,000 potential schemes, and he'd constructed 50. And that's the Mount Everest that this industry is facing. 28,000 schemes he looked at in 5 years, and he's built 50. Why is it taking so long? Why are you spending so much money? So, by way of background, for any of those who don't know where Lancaster is, and where this site is that we are trying to construct this turbine on, it's, if you can see on the left-hand screen, it's just to the east of the M6 motorway. That's the main campus, and that's where we're trying to construct the turbine. And you will be able to see it from the M6, going both south and north. So, we've got, as you saw there, we've got a nice, clean piece of land. We're very fortunate. We've got a nice, clean piece of land to the east of the M6. From memory, it's about 50 acres. And there's just a couple of cows on there. And we've got a Met station, if this thing will work, just to the top of the red square. Which we've had an anemometer there for 20 years, a 20-metre high anemometer. So we've got 20 years of wind data at 20 metres high. Now, I think I meant to add at the beginning, I'm not a wind turbine expert. I don't pretend to be. And this is about sharing our experience and the knowledge I've built up in the last 2 years and sharing it. If anybody wants to speak to me after this conference, I'm more than happy to come along. Well, so we've got a nice site there. We knew we had wind speeds at 20 metres at about 6.5 metres per second. So you would think the wind turbine was viable, very viable. But if you're going to build one of these wind turbines, the first thing to do is a very quick site constraints map. Because you can understand these developers, if he's looking at 28,000, he needs to make a fairly quick decision about which ones are going to run and which are not. So you do a desktop study. And you start to look at some of the site constraints. Now you have to build a gap, a barrier between the perimeter of your land and the turbine tip for oversailing purposes. You don't want to be oversailing onto the motorway or oversailing onto somebody's land. So you build in a small strip. So straight away you can see now the site's already starting to be constrained. You can see in the yellow, that represents a radio communication microwave link. Now they work on line of sight, and you can't construct, as a rule, without going into much more detail and talking to the people like BT and Orange, whoever's got a mast there, you need to be 50 metres away from the centre line of any microwave links or any radio communication links. So you can see there now that the site's starting to becoming more constrained. You then come along, something comes along, I didn't know about this in August 2009, but there's topple distances. So the Highways Agency set a constraint on you of topple distance. And it's simply, if it falls over, it's not got to fall onto the motorway. Now when we started this, they used to say tip height plus 10%. Now when we started this scheme, we had 2 turbines, 125 metres each to the tip. So you have to add on, at that time you had to add on 10%. So 10% 125 metres, 137.5 metres. So you got to be 137.5 metres away from the motorway. Now that would have, and on a B road, it's still top height plus 10%. So from the B road, which is the top road, the one in yellow, we also had to be 137.5 metres there. So you can see now that the sites, suddenly from having this 50-acre site, so at that point we decided to reduce the height of the turbines to 100 metres, not 125, because also right in the middle of the design, the Highways Agency changed the rules from topple height plus 10% to topple height plus 50 metres. So a 100-metre tip plus 50 metres meant 155. 125-metre tip height on a turbine would have taken us to 175 metres. So it would have near enough made the site unusable. So we went down to 100 metres plus 50. So we had to be 150 metres from the motorway and 110 metres from the B road. So you can see the site constraints now, that the map. And the bits in the middle, the bits where we think we might be able to build these 2 turbines. You then have to overlay any pylons. Now, fortunately, I've put these on just to show the pylons, I think the 400 kV pylons that go over there, are outside our boundary, but if they were inside, then we would be 50 metres from any pylons. Just in case you decide to build one near some pylons. Here, the next one shows any water courses. Now, it isn't impossible to build a turbine on a water course, but it's best to be avoided because you will need to deal with the ecologists and the Environment Agency, Natural England, the county ecologists. So and you really don't want to go there if you have to. So you wouldn't really want to be building on a water course, which you can see, because my little red thing isn't working, it's down the centre of the site. So then there are houses, there are residential houses. Now in England, there are no minimum set distances that you have to be from residential dwellings. There are in Scotland, and I think there are in Wales, but there's not in England. Most countries in the world do have setback distances, but they don't in the UK. But you'll see some circles. You can see the circles where we put circles on the map to highlight where we thought there would be an issue due to noise or shadow flicker, which I'll come on to later. So again, these circles around these dwellings are starting to constrain the site. Then there are woodlands, and it's best again if you're not going to take any trees out. So, I mean, it's getting difficult to see now, and I can't, it's a shame this won't work, but there are some, there's some dark green sections which identify the woodlands. Now, you can take woodlands out, but again, you're going to have to deal with all sorts of people and organisations who don't want you to do it. So you can see the site constraint map. Now, after carrying out this desktop study, there's 2 black dots. Now, but believe it or not, there is a gap. The one on the right, there is a gap there. There's a white space where we can put a turbine. And the one on the left, well, there's quite a bit of space there to build 2 turbines. Now, the senior managers and people on the estates committee were saying to me, why are you not building 20? Now, there are other constraints as well about the distance between 2 turbines. Okay, now really, you want to be about 10 tip height differences, distance between 2 turbines. If you get within 5 or 7, they start having an effect on each other. And the providers, the manufacturers, start to get the jitters and don't want to do it. So there are other constraints. You can't just build them all next to each other. They need to be at a certain distance apart. So we thought we'd identified 2 possible locations. So then I said, right, okay, design team, let's start work on these 2 turbines. Let's see if we can get planning permission. And just to summarise why we picked the Hazelrig site, it's the highest point on the campus with the highest wind speeds. We'd got the long-term data that we knew we'd had average wind speeds of about 6.5 metres per second, which made it financially viable. It was relatively remote. There was 6 or 7 properties involved close by. But we did assess the whole campus. And this was felt to be the best site of all. Now, I learned some of these things the hard way, and it's trying to pass this information on. But you can, because I cannot believe how naive I was now 2 years ago about constructing a wind turbine and getting planning. But there are things you need to do in the right order. And one of the things that you do need is wind speed at hub height. It's not really that useful having wind speed at 20 metres. If you're going to build a turbine that's got a 60 or 70 metre hub, you need to measure the wind at that high. How do you do that? Well, you have to get a Met mast. Now, there are 3 ways you can do that. You could buy a new one, you can buy a second-hand one, or you can rent one. It's quite an expensive thing to do, and you'll also need planning permission to put it up. And if you think you need 12 months data, you need to buy it, you need to install it, you need to get planning permission for it. So you could be 15, 18 months before you've got this data. Now, I think we went on eBay and we found a second-hand one. Yeah. And we paid £10,000 for it, and then £10,000 to have it removed from where it was and installed. And it monitored wind speed for us. We found it was somewhere between 6.5 and 7.5 metres per second after the 12 months. It's essential. The next thing I've learned is that you have to get grid connection, which is anything but simple. How do you get grid connection? You go to your local DNO and you say to them, can I connect my wind turbine to your grid, please? And they say, yeah, that's okay. We'll have to do a model. We'll have to model it for you. Okay. Will you model it for me? Yeah, that's fine, but it's £10,000. So they charge you £10,000 to model your grid connection. And then they tell you how much it's going to cost. Because the issue here is fault level. That they're concerned about the additional fault level your piece of generating kit is putting on their network. Now, the cost of this grid connection is unknown. And if you get involved in these projects and some financial director saying how much is this going to cost, you don't actually know how much this is going to cost at that time when you've got to connect to the grid. The other thing with dealing with the DNOs, they take up to 3 months to acknowledge receipt of your application. And then they're supposed to deal with it, but they don't. And if you want to complain, you're more than welcome to try, go to Ofgem and see how far you get. So you have to cajole these people. You've got to go down there, really work with them, take them to lunch, take them to try and get them to work on your project. It's not easy. Fortunately for us, they said we could have the grid connection, and the reinforcement charges were only £10,000, which is a very small amount of money. I have heard of people paying £250,000 to get some reinforcement work done. So again, it's another one to start early to get the grid connection. Now, another thing I've come across with this industry, and I touched on this last year, was that it's like no other I've come across. I mean, I've been working in the construction industry in one form or another now for 40 years, and this industry is completely different. If you think about 28,000 schemes looked at and 50 built, they have to be very careful about the schemes that they're tendering for. They have limited resource and they don't tender lightly. Some of the organisations even need board decision to put a tender in. So you have to have a checklist of 4 items. My experience is that you'll be very fortunate to get any tenders unless you've got planning permission, unless you've got a letter, and you can show them a letter that you've got grid connection. They'll want to see 12 months wind data. If you haven't got it, it'll be very low to tender. And they want to know you've got the money. Because if you're dealing through a bank, they get very nervous because the bank's due diligence will take forever. So my own plan with this was I went to the British Wind Energy Association conference in October 2009 with a plaque on either side, and 5 million, I had 7 million then, £7 million hanging out of my back pocket saying I've got planning. I didn't have actually. I've got grid connection, I've got 12 months wind data, and I managed to find 3 organisations that were willing to tender. I then visited them all and warmed them up. I would phone them monthly and tell them about progress with the project. I explained to them about ODU. All 3 of them said to me, "What's ODU? Don't think we're going to bother with this. It looks complicated. Why do we need to bother with this?" If you're only wanting to build 1 or 2, they really don't want to know. Now I can't tell you how much effort I put into getting these 3 contractors to be interested in this project. We went through the ODU process and the only 3 tenders we got are these 3. Now I'd learnt this the hard way. I'd gone to see the University of Ulster and they'd gone out through ODU. They tendered for a turbine, 750 kilowatt, and they got 1 tender back. So you've got to be thinking about getting people interested to hook them in very early. Have you got a unique selling point, something they're interested in? So you've got to think about how you're going to get tenders. Are you going to be sat there opening your ODU with nobody tendering? Now, why is it taking so long? Why are you spending all this money? One of the other issues, or one of the other items, you, as part of the statutory consultees, you will write out to the MOD, NATS, and any local airports, saying, we're going to put 2 wind turbines up. Have you got any objection? And they'll write back saying, yeah, they object. They will do that straight away. So you'll have to go and see them and say, well, why do you object? And they'll say, we always do. So we say, well, right, well, how do we get around this? well, we'll have to model your turbines on our radar system. Okay, how do we get that done? Well, you have to give us a cheque for £10,000. So I give them a cheque for £10,000 and ask them to model it, and they model it. And then they came back and said, well, it is going to interfere. You're on a flight path and it's going to interfere. So you need a tag. What's a tag? Well, it's one of these things that it's on the radar and they block out the turbine and they fly around it. Right, where do we get one of them from? Well, you go down to the MOD site and you'll see an office and it's above it, it's got tags. And you go down there and you'll see a queue and you get in the queue. So I go down to the MOD office and there's a queue. Fortunately, there's one person in front because these tags are given out on first come, first served basis. And the first come, first served basis is who's got a planning application in and the date of the planning application. Now, the poor chap who was in front of me was from BT and he was trying to build a turbine in the Morecambe Bay. And his went to planning, and if he'd got the tag, we wouldn't, and that bee was finished. Now, unfortunately, his was pulled for whatever reason, and I got to the front of the queue and got the tag. There were 5 behind me by this time, hoping that I was going to fail, so they could get the tag. And forever ringing up the MOD saying, we're still going through, we're still going through. Please don't give my tag away. And we've still got that tag now. So you need to be getting in early and talking to the MOD. Now, as you saw on there, we are going to build this turbine on the east side of the motorway. And we have our own HV network at Lancaster, which is quite good for a network, for grid connection. But we need to get under the motorway. Now, we started some conversations and discussions with the Highways Agency about drilling under the motorway and putting a cable under. And after 2 or 3 meetings, just decided to abandon this idea because they really, if you're not a statutory body, if you're not CGB or National Grid and you want to drill under the motorway, they don't really have a facility for you to do that. It doesn't really come onto their radar. So, and it was even looking at some of the cost, it was going to be a phenomenal cost to do this. So we decided that we would run down the field, get onto the B road, go along the B road and back up into the university. So approximately 2 kilometres. Now, again, I wasn't sure about running our own HV cable in a public highway, and now we do that. But we got the county council, and they seem quite relaxed about it, and so that's the road we've gone down. But again, we're going to have to close the road. How do you close a B road? How much notice do you have to give? Now, when we finally get into delivering this turbine to site, the blades were 41, 42 metres long, and so the wagon, the lorry, is going to be about 50 metres. Now, as part of the planning application, you have to do an access strategy study, a traffic management plan. You've got to put that in as part of your planning. And that entails a surveyor walks the route, takes some dimensions, and then models this blade going round the bends. And this particular study, I think you've guessed it, costs £10,000. And that goes in with your planning application. Now, we're actually taking out a significant number of lampposts. We're taking out a set of traffic lights. We're taking out bollards. We're having to construct a temporary road over a roundabout because it can't go round a roundabout, this thing. The logistics of this and the planning of this are very extensive. Because my worst fear is that we've not done something we should have done, and this turbine comes all the way from Germany and it's stuck under a bridge somewhere. I think my phone will be off the hook. There's then the issue of TV interference. And so you'll have to, as part of the planning application, you'll have to establish that you're not going to interfere with anybody's TV signal, or if you are, what are you going to do about it? So There is a BBC tool on the website you can use to see whether you are going to interfere with people with a terrestrial telly. But I don't think the planning authorities would be too pleased if you just put that in. So you have to do a study. And that study has to be done before and after you construct the turbine. So before you construct, it's a man in a van. Well, first of all, it's a desktop study to see how many houses may be affected by this turbine. And it is a simple thing, as I've got my head around it, is that you have a transmitter and you've got an aerial. If you put the turbine within the Fresnel area of this signal, then the TV signal arrives slightly, gets reflected and arrives slightly later and interferes with the television signal. So a man in a van, round he goes, he measures the TV signals, all these properties that might be affected. And then afterwards he has to go around again and see that the signal's not deteriorated. And again, you've guessed it, this costs about £10,000. Why is it taking so long? Why are you spending so much money? Another issue, and I haven't actually got time to go through them all here this morning, but another issue is shadow flicker. Now, this is a phenomenon whereby at certain times of the year when the sun's low, you get a shadow that cuts across a residential property and is a nuisance. Now, as a rule of thumb, shadow flicker will occur at 10 times the diameter of the blade. So if we've got an 80-metre diameter blade, up to 800 metres, as a rule of thumb, they could be affected by shadow flicker. So if they could be affected by shadow flicker, as part of the planning application, you have to produce a study that's done on a piece of software on a computer to show which properties will be affected and for how long. Now, there are no UK standards associated with shadow flicker. There are German standards that we seem to work to, and they say if it's affected for more, if a property is affected for more than 30 hours a year, you have to provide some sort of control mechanism in your turbine that'll shut it down when shadow flicker is occurring. So again, you do the study and you submit it. And the planners will inevitably put a condition on you saying you must have a shadow flicker control system in your turbine. It'll shut it down. Why are we building this turbine? Two reasons. One's carbon reduction. Second one is financial payback. Now, you know, it has become apparent to me, it's not rocket science, this, the economics of wind turbines. You pay about for a 2.5 megawatt machine, 2 megawatt machine, you can purchase that for about €2 million as a standalone piece of kit. Now again, when we started this project, you were getting 1.30 euros to the pound. And now you're getting about 1.12, so it's had a major impact on our budget because you have to buy these things in euros. So €2 million, about £2 million for the machine. It depends on your infrastructure. You've got your base, you've got your access roads, you've got your HV cabling. It could be anywhere up to £1.5 million for your infrastructure works. Probably about £500,000, £500,000 for all these £10,000 surveys, consultant fees, planning applications, PR campaign, which I've not touched on yet. So you're talking about 4 million, plus some contingency, plus VAT, if you can't claim the VAT back. Now, a 2.5 megawatt machine will generate about £600,000 worth of revenue for us from a mixture of electricity and the feed-in tariff. So the feed-in tariff at the moment for a 2 megawatt machine is about £50 a megawatt hour, and you can calculate the average price of electricity over the next 25 years, 10p a unit. So it's quite easy to calculate. These things have got a payback of about 7 or 8 years. They've got a life of about 25, so, you know, for 18 years, you're going to be making about £10 million. One of the issues is about the wind speed. I'll have to speed up a bit because the relationship between wind speed and yield is not linear. So if you vary the output from a 2.5 megawatt machine will vary between 6 meters per second wind speed average and say 7.5, the output will double. So over a period, over a range of 1.5 to 2 meters per second, the output will double. Now, some finance director will be saying, how much are we going to, how fast the payback, how much are we going to make? And it really is dependent on that wind speed, and that's why you need that 12-month data to get some reliability into this. But at Lancaster, between wind speeds of 5.5 and 7.5, 8 meters a second, will produce about 4,000 to 8,000 megawatt hours a year. So carbon saving, off the top of my head, 2,000 to 4,000 tonnes, somewhere in that region. So I'm quite relaxed about 2,500 tonnes saving. And that, will be, we should be able to get, with one turbine, 10%. If we had two, maybe about 17% carbon saving to the university, which is fantastic. Noise is another issue. And again, you'll have to do a noise survey before you... that's the sound of the turbine in the background. The main noise is aerodynamic, it's not mechanical. And there is planning guidance on this, UK planning guidance or England planning guidance. And rule of thumb-wise, you are allowed 5 dBA above background noise. So you have to commission a study to go and measure the noise levels at properties that might be affected by sound, which we calculated, we think was 6 properties for a week. And really they like to see different weather as well. So they like the noise survey to be done when it was windy, when it was still, and when it was raining, because it might have an effect on the background noise. And then you permit it, and then you have to do a computer model to show you superimpose the turbine on top of that to show that it won't increase the noise levels in residential properties by a further 5 dBA. And our model showed it would go up from 40 to 43 dBA, but I don't think it's getting very tight, this. There's not a lot of room for error because, again, on completion, you've got to go out and measure it again to prove that your mathematical model actually works in practice. Now, again, you have to have a mitigation control system inside your wind turbine. Should it go over this noise level threshold, the machine shuts down. Again, that study, £10,000. And then you've got to start dealing with the ecology and the environment. Bats, badgers, birds, newts, salmon, spiders. It goes on and on and on. And you meet with Natural England, you meet with the local ecologists, you get faced with all kinds of statements that you go outside of meetings shaking your head, you just can't believe what's being said. Now, there's a recent case, the Eagland Hill turbine, that was, it recently went, it's in Garstang, Lancashire. This one went to the High Court because they determined they were going to kill 50 geese a year. And the High Court had to decide whether it was okay for a turbine to kill 50 geese, whether that was environmentally acceptable against the balance of the benefits of low carbon. Now, I've had things said by senior members of the council. He'd taken his dog for a walk and he'd seen turbines killed bats, so he couldn't vote. Another one said he thought the salmon would stop swimming up a 18-inch stream, and so he couldn't vote. Somebody else has said they'd read something on the internet, and that made him. And these are the kind of prejudice that you've got to deal with to win, to gain planning permission. This is one scheme. As I showed last year, this is just one of the schemes we're dealing with. We're doing the Energy Centre, which gets handed over 1st of November, which is a CHP, low efficiency gas boilers. We've installed 500 energy meters. We're doing energy surveys in 60 buildings. We're doing an awful lot else. I just always like to say this is not just one project that we're just doing. It's one of many we're actually on with as part of our sustainable energy infrastructure. In 2009, August, we set off on this journey. In the May 2010, we got planning refusal for 2 turbines. We took QC's advice on what we should do, and he advised that we should go back with 1. We went back to planning in October 2010 with 1 turbine, and we got a planning resolution in April 2011 to let us build the northern turbine. 12 votes to 7. 1 abstention, 12 votes to 7. Two votes either way, and we're not building it. It's as close as that. All 2 years hard work, and you sat in that planning meeting and you're sweating cops because you can see the debate and you can't say anything. The planning resolution was passed, but then, before we received the planning notice, we received legal challenge to the council that the council hadn't followed correct protocol. Council took QC's advice and decided they had. They've now moved forward and issued us with the planning notice on the 11th of October. There's now a 13-week period such that there can be a judicial review challenge. Hopefully there won't be. And then on November the 10th, we can start, we can place an order with our preferred bidder, because we managed to get 2 bids in for the single turbine. So that's where we're up to, and I'm hopeful, very hopeful, that this time next year it will be constructed. And I think that's an overview of what we've been up to at Lancaster, trying to construct this turbine. Financially, we did, in early 2009, we were fortunate to get the revolving green fund. And HEFCE have maintained their support for us right through this process. And so because of the VAT, we'll be paying 500,000 VAT on this project, 800,000 pound VAT, they're supporting us for £5 million. So 1.6 from the university, 3.4 from the funding council. And we have to pay them back on the savings that we make over the next 7 to 8 years. So, I've learned, so, you know, there's questions and answers, fine, I'm happy to take those, but I have gained a lot of knowledge in the last 2 years, and anybody who's thinking, and I'm concerned it's just going to go away and I won't be able to ever use it again, so I'm more than happy, absolutely delighted, if somebody wants to say, you know, can we come and see you at Lancaster, can I come down and have a look at your site and see what I think? And I do know a few people in the industry who are very trustworthy, and you'd be better getting a view from them probably. So anybody who wants any advice afterwards, please don't hesitate to give me a call.
Well, thanks, Mike, for a very informative presentation. I think at Edinburgh we've already experienced some problems with utilities companies trying to install generation sets. Like, additional usual appreciation for Does anybody have any questions for me?
I've got a question. I mean, that was a fantastic talk. I don't want to ask you a question, but to ask you to value it for the last year and a half. I mean, it was interesting, the MOD, did you need to engage with the Civil Aviation Authority?
Yes, we did, yeah. But the one study seemed to unlock the system for us. They all seem to be quite, well, once they'd seen the radar plot done, they were satisfied. Now, some developers have said to me, well, if you can't get a tag, there's another way around this. I don't know what that is, but I know a man who does. Unfortunately, we've not had to go there yet.
Costs involved there. Did you consider perhaps a PFI scheme, and do you see any advantage or disadvantage with the PFI? You've got funding now, so do you think a PFI scheme would have been a smoother route to get?
It's obviously less riskful, isn't it? And the developers, there's a turbine gone up probably about 30 miles away from us, and that's a PFI project. And I've been following it and talking to the developer. And what he's doing there is that he's constructing it for free. He's taking the risk with all the planning issues. But he won't do it unless he's got certainty. And they're quite good at it. They're in a different league than I am. 28,000, he knows which ones are going to get through. So you're taking the risk out of it. What he's taking the feed-in tariff, and he's letting the landowner get free electricity, or he's charging them, I think, actually, a very low rate for the electricity, and he makes that stack up as a business model. Now, the thing I've not been able to get my head round, and you'd have to talk to Ofgem about this, I'm not sure where the carbon credits go on that kind of a model. Because one of the big drivers for all of us is to reduce carbon, isn't it? And if you can't claim the carbon credit, then why are you doing it? Well, you might want to do it then as a money-saving exercise, because it'd be cheaper electricity than coming off the grid. But I think you do need to look at that. Now, one of the things I have spoken to Ofgem and said, can we claim carbon credits? They said, well, you can claim you're reducing carbon. You can make the statement. But, and it's 18 months since I spoke to them, so it may well have changed, but they said, if you take a rock or a feed-in tariff, you can't then take £12 a tonne for your carbon reduction commitment, because you're taking double monies. What they said to me is you can't take double monies. Now, that was a conversation with someone who seemed to know what he was doing 18 months ago. So I think those are the questions to ask. And with hindsight, these developers are so much better at it than we are. And I think it's 50-50. Would I go down that route now? I'm not sure, but I'd certainly consider it. You definitely do, because they tend to be bulk buying, so they might have 10 schemes going on, and he buys 10 turbines at once. He's got relationships with the industry. The only thing I think is some of these developers use bankers' money, and that can get a bit difficult for them, because certainly if you start showing them £5 million, then they start to listen. But they change so quickly. I mean, the production times as well. You could be 6 months. You could be 18 months. It depends when you get your slot in a factory. You don't buy these things off the shelf.
Did you get any neighbouring property objections?
Yeah, I haven't really touched on the PR side of it. On the 2 turbine. Application, we tried to do the PR ourselves. I would advise you not to do that. We didn't know what we were doing. We didn't have a clear strategy. Because what you want to do with a PR campaign is, it's no good the university saying this is the best thing since sliced bread. We would say that, wouldn't we? You've got to get the locals saying it. Now, what I find is the objectors are very vociferous, and the people who support wind turbines tend just to sit at home and don't think they need to say anything. And you've got to mobilise that support for them to say it. And, the money would be well worth spent. On the second one, we employed a PR consultant. And it's, I think, some of the best money the university spent. Yeah.
Where, you know, neighbours are saying drop in value of property, loss of sleep. No concern with that?
I'm not sure where those claims would go, whether they would go against the local authority for issuing the planning permission. I don't know, to be honest. I'd have to take legal advice, which, again, on this, I seem to be on the phone to our legal advisors, our lawyers, quite a lot. What happens now? And the other thing we've done on that PR thing, we did 5 public, like a roadshow, you know, inviting the public in to talk to us. And the verbal abuse I got, I've never experienced anything like it. And in one of them, I had 30 people coming onto me, and I said, if you don't back off, I'm leaving the room. If you don't stop now, I'm leaving. You know, I thought they're getting out of hand. And, you know, just by way, I just like, I know it's running over, but how many people in this room are pro-wind? Could you put your hand up? Right, so that's only about a third. So 2/3 of an engineering organisation are not pro-wind. And that's what you're up against when you try to get this planning permission.
Any other questions?
After 365 days a year, how much are you expecting this to operate?
They have a utilisation factor around 30%. So it'll be turning for equivalent of 30% of its full output if it ran for a year, 30% of the time. But that's the business model's based on that. We've taken that into account.
Do you think you'll achieve that? I'm just thinking of the number of wind turbines you see around the country that are not too.
Yeah, I mean, we've done the 12-month wind data modelling. And I know I said you should get it at hub height, we've got 20 years at 20 metre. And what we've done is, for the finance director, is we've got a sensitivity model. So if the wind didn't blow as much, or it blew more, the price of electricity goes up and down. So, you know, we've got a payback period somewhere between 6 and 10 years, depending on the price of electricity and the amount of wind that happens. And probably it's going to be 8. And most of the developers say, you know, reinforcing that to me, which makes me feel I probably won't be getting the sack.
Do you have an upper limit for your wind speed?
Have we? Yes, it shuts down. I think it shuts down 25 metres per second. Becomes unstable then.
What's your investment been to date?
What's?
How much money have you spent to date?
We've spent £1,000. Yeah, it will cost about, it'll cost you about £200,000 to get to planning and about £200,000 to construct it. Because it doesn't stop. Once you get your planning notice, we've got 26 planning conditions on us now to release. So those will be in more £10,000. So that could be a model for the PFI, but I think you need to make sure, if I was going down that road, can I claim the carbon? I mean, I think you can in your carbon management plan. You might not be able to claim the £12 a tonne, but you should be able to say, I met my 43% target by 2010 by putting this turbine up. I don't think that is an unreasonable statement to make.
Any more questions? On behalf of the association, I'd like to present Mike with a token of appreciation. Small gift. Thank you, Mike.
Thanks very much.
Thanks very much.